Choice. In behavior analysis, we define choice as the allocation of behavior over time. It is not internal decision or resulting action of some internal processing. Remember, we're behavior analysts here. We're going to talk about behavior. We're not going to talk about mental events that we can't really see, and we don't know whether they're going on or not. We don't have confirmation of whether you made a mental list or not, or if you decided to weigh the pros and cons privately without us knowing, without us seeing them. What we're going to do is try to account for allocation of behavior independent of what might precede that. In that view, in our view, in behavior analysis, choice is behavior. The matching law was proposed by Richard Herrnstein, and originally, it's had decades of work, and I love the matching law. I mean, I think I've used to joke with students that I'd marry the matching law if I was already married. Actually, I think I'd marry Excel first, and then I'd marry the matching law. Well, whatever. Okay, I get lost. The matching law applied to two behavioral alternatives. Basically says that this is behavior, this is the reinforcement rate. What it basically says is that behavior will be allocated in a ratio that equals the relative reinforcement ratios. So what we have is B1 over B1 plus B2 is equal to R1 divided by R1 over R2. If we apply it to three alternatives, or four alternatives, you can see that we can expand the behavior, the matching law, to account for situations in which there's a lot of different things to do, and you do one, or how often are you going to do one relative to the others? Because it actually turns out that, depending on the circumstances, you do one thing over another, right? So when we apply it to two behavioral alternatives, what we found is that the matching law, the allocation of behavior, how much time or how many resources are we going to apply to this one alternative is going to be related to the relative reinforcement, the rate of reinforcement, relative rate of reinforcement of all the alternatives. That's one way to look at it. But research has also shown that the amount of reinforcement, we can look at behavior and its allocation in terms of amount, in terms of immediacy, and in terms of even one group of researchers argued that you could look at quality. Matching law has been widely applied to pigeons, rats, and people. Believe it or not, we've done matching law analysis on people purchasing things, time allocation and studying, basketball shots, stock market. It's been applied over and over and over again, and basically what it shows is that the allocation of behavior on one alternative will match the relative amount of reinforcement from that alternative. Now, I'm doing a little algebra in this slide here to basically show you that B1 divided by B1 plus B2 equals R1 divided by R1 and is R2. If I do a little bit of rearranging, I can show that B1 divided by B2 is equal to R1 over R2. These two statements are equivalent mathematically. And here I just multiplied both sides, like I multiplied B1 times R1 plus R2, R1 times B1 plus B2. If you see, there's B1 R1, B1 R2, R1 B1, R1 B2. What you can see is that this term and this term are identical. B1 times R1 is the same as R1 times B1. So those drop out, so I wind up with B1 R2 is equal to R1 B2. And if I divide the other side by R2, if I divide both sides by R2, I get B1 is equal to R1 over B2, R1 times B2 divided by R2. And if I divide both sides by B2, this is what I get. So I can show you that they're mathematically equivalent. Now, the reason I want to show you this is that the matching law is very useful. If in fact this is the case of allocation of behavior in situations where we have multiple alternatives, there are a lot of uses. The rate of behavior 1 depends on the rate of reinforcement for option 1, right? We know that how fast, how often, how frequently, with how much force and vigor the you do some behavior is related to its rate of reinforcement. However, it is also related to the rate of reinforcement for option 2. It's not just a function of R1, it's also a function of R2. So, if the rate of R2 reinforcement for option 2 goes up, what we will see is we will see a decrease in behavior 1. If you decrease the rate of reinforcement for option 2, according to the matching law, you should see an increase in the rate of behavior 1. So, those are some applications of the matching law. That was just an introduction to choice, but the matching law is widely applicable, and some of the implications, hopefully, you see now.